Hi, I'm Kian, and in this video, I'm going to show you how to solve this simple but neat trigonometric integral. So we have the integral of 1 minus cosine x over 1 plus cosine x. So the first thing I want to do is maybe simplify this a little by multiplying by the conjugate of the denominator. So we can multiply by 1 minus cosine x over 1 minus cosine x. And if we do, we get the integral, and then the top would be 1 plus cosine squared x, and then minus 2 cosine x. And then we have over, this whole thing over, and if we multiply by the conjugate, we get 1 minus cosine squared, which by identity is basically just sine squared x. And then we have also the dx here, which I'm going to write it a little here. Now, we can actually simplify this by splitting it up. So this is the same as writing it as 3 separate integrals. So the integral of 1 over sine squared x, which is cosecant squared x. Also, we can write it as plus the integral of cosine squared x over sine squared x, which is the same as integral of cotangent squared x, but I'm going to write cotangent squared x in terms of cosecant squared x, and I'm going to explain why I did it. So this is the same as cosecant squared x, and then minus 1. And lastly, I can also write this as negative 2 integral of cosine x, and then over sine squared x. And I'm going to leave out the dx here because I don't have much space, but you know that you have to always have the dx. I'm going to add this for this one. So for the first integral, I'm going to use a different color, maybe purple. So for the first integral, cosecant squared x, this is the value of cosecant squared x. The integral is just negative cotangent x, which is known. And then plus the integral of cosecant squared x minus 1 is the same as saying, again, it's negative cotangent x. So I'm going to write this basically as negative 2 cotangent x, and then minus x. And then this was why I turned the cotangent into cosecant squared minus 1. The reason was because we can't take the integral of cotangent squared x just by the alone. We have to turn it into, this is the same with tangent squared x. If you want to take the integral, you have to first turn it into secant squared x minus 1. And lastly, this is a u substitution problem. So if you let u to be equal to sine x, we can see that in this case, du would be cosine x, and this would cancel out, and we would have 1 over u squared. Integral of 1 over u squared is negative 1 over u. So the negative and negative cancel out. It becomes a plus 1 over u, but u is just sine x. Or we can rewrite the 1 over, or we can rewrite this again as negative 2 cotangent of x minus x, and then plus cosecant x. And then we have the plus c at the end. And thanks for watching.